This video is going to make you smarter than most students when you come across an SAT question like this. If p to the power of 3 is equal to 2, then 8p must be equal. I know you'll be tempted to work it this way. P to the power of 3 is equal to 2. Take away the roots. When you take the cube roots of both sides, this has cancelled this, so p becomes cube root of 2, which is still same thing as having 2 to the power of 1 over 3, right? Changing root to fractional index. Now you now say that 8p is equal to, and 8 means 2 to the power of 3, right? Times p, and this is now p, 2 to the power of 1 over 3. When you resolve this using the product law of indices, multiplication law of indices, it becomes 2 to the power of, when you're multiplying powers with the same base, you take one base, you add the powers, 3 plus 1 over 3. Only that this is not giving us any of the correct options, so that means we need to think outside the box. So thinking outside the box, recall that p to the power of 3 is equal to p. So 8p is what they want you to find. 8p will be equal to. Now recall that p to the power of 3 is equal to 2. Now let us start with here. We can change 8 to become 2 to the power of 3 multiplied by this p. Now this then means that if you're watching any place you see p to the power of 3 is equal to 2. Or you can say 2 means p to the power of 3, right? Now there's a 2 here. I'm going to change it to p to the power of 3. So this becomes p to the power of 3, or raised to the power of 3 multiplied by another p. When I resolve this bracket from the rule of product of indices, I'm having p to the power of 3 times 3 gives me 9 multiplied by p. Now p is just like having p to the power of 1. Any value has 1 as its power or exponent. Now from also the multiplication rule of indices, since they have the same base, I take one of the base, add the powers, it becomes e to the power of 10. This is the correct option.